Hi there, Karnika here, and welcome back to Kaggle Competition Chronicles. Today we are exploring something I've been really excited to share with you, AutoGluon. If you've been on Kaggle lately, you've probably heard about how powerful it is. AutoGluon has been making waves on Kaggle recently because how quickly it helps people climb the leaderboard. And in this video, we're going to see it in action with one of the most iconic competition on Kaggle, the Titanic Disaster Challenge, which, as you probably know, is a classic binary classification challenge. We'll be predicting whether a passenger survived the disaster based on the features like age, gender, fare, and class. As much as I love feature engineering, for this project, I've already done some basic stuff, like creating new features such as family size and cleaning out salutations. But here's where I get fun. I'm leaving a lot of heavy lifting, like handling missing values, encoding, scaling for AutoGluon to handle. Why? Well, let's face it. If AutoGluon is ready to do it faster and better, I'm happy to delegate. Before we dive into modeling, let's get AutoGluon installed. It's super simple. We're going to see why AutoGluon is such a game changer, especially for competitions like this. We've got your typical Titanic data. I've already done some work of feature engineering, nothing fancy, just created a few new variables, like I said, and I've left the fun part out, handling missing values and encoding categorical variable for AutoGluon. And it'll take care of that for us, because why reinvent the wheels? That's what someone in corporate probably said. Alright, time for the fun part. Training our basic model. Now, with AutoGluon, it couldn't be easier. We're going to use tabular predictor, a function to train our model with minimum code. I'm going to use preset option set to best quality, which tells AutoGluon to focus on giving us the highest accuracy model. Think of it as telling AutoGluon, give me your best shot. I've also set time limit of 600 seconds, so it has the minimum of 10 minutes to explore multiple models and figure out the best approach. AutoGluon is going to try out models like LightGBM, random forest, and more, and we'll see what comes out on top. AutoGluon makes me feel like I'm doing a lot when really it's doing all the heavy lifting for me. Now, here's where things get really interesting. Once we have created our baseline model, it's time for hyperparameter tuning. This is where AutoGluon really shines. It's super flexible, so you can tweak things, explore different settings without needing to be a machine learning wizard. For this step, I'm going to select 3 models that did well in our baseline: LightGBM, CatBoost, and XGBoost. We'll tune some parameters like number of boosting rounds for LightGBM, learning rate for CatBoost, and the number of estimators and maximum depth for XGBoost. You can play around with these settings yourself. AutoGluon makes it super easy to experiment. And if you are the kind of person who likes to dive into the weed, there's a lot more you can do here to fine-tune your models. But remember, it's all about finding that right balance. Don't overthink it. Sometimes less is more. Come here. I guess we're going to be joined by very cranky Epoch here. She's making a lot of noise. Next up is Ensembling. This is where AutoGluon really flexes its muscle. Instead of relying on just one model, AutoGluon combines the prediction of several models to create an ensemble. And it's like having a team of experts rather than just one person. In this case, we're going to use 5-fold bagging, where the data is split into 5 parts, and AutoGluon is going to train different models on each part. And we're going to stack 2 levels of models. So we're not only combining multiple models, but we're also training new models on top of that. It's like getting a second opinion, and then third, until you have a decision you can trust. And trust me, ensembling almost always improves the performance. Now, here's where we take ensembling up a notch. AutoGluon gives us a leaderboard of models ranked by their performance, and we can pick the top model to build a custom ensemble. Let's choose top 3 models, or 5, to refit them for our final ensemble. This ensures that we're using only the best models for our experiments. And what we're doing here is bringing together the best performers and letting them work, kind of like forming a dream team. We're essentially saying, let's take the top 3 and make them work together for the best possible prediction. Alright, now let's bring all this together. We're going to use everything we've learned, hyperparameter tuning, bagging, stacking, ensembling into one final predictor. And this is where AutoGluon truly shines. By combining all these techniques, we are getting most of each model, ensuring that the final ensemble is as strong as possible. We're selecting LightGBM, CatBoost, XGBoost for hyperparameter tuning, bagging the results, stacking models, and then ensembling them into one final predictor. It's the ultimate combination of everything AutoGluon has to offer. Now we're ready to make our final prediction on the test set. Once we've got the custom ensemble, we'll make the predictions and prepare the submission file. And that's it. We've trained the model, tuned the hyperparameters, and built an ensemble. And now we're ready to submit on Kaggle. I can't wait to see how this model performs on the leaderboard. There you have it, a full walkthrough of AutoGluon. We started with some basic feature engineering, let AutoGluon handle data processing and model training, hyperparameter tuning, and ensembling. AutoGluon is like having your own personal data science assistant, and I have to say it's a huge time saver, especially in Kaggle competitions where speed and accuracy are everything. I hope you found this video helpful, and if you did, don't forget to like, share, subscribe, and let me know in the comments which models you are using and what parameters you're setting. I'll see you in the next video.